Hello, fabulous pre-cal students. Today we're looking at assignment 28. And it's all about essentially distance and midpoint formula and applications of those things. So, I don't want to make this assumption, so I thought I would start by asking you this question. Imagine you have a triangle here with this ordered pair, x1, y1. These subscripts, they're not mathematical numbers, they're names. This is the x value of the first point and the y value of the first point. And over here I'm going to put x sub 2, y sub 2. These aren't exponents, they're names. This is the x value of the second point and the y value of the second point. Now, what would this ordered pair be if this were a right triangle? So, this x value is the same as this x value because they're on the same vertical line. And these are on the same y line, so the y value here is the y value here. So, if I want to describe this distance, I can think about it as x sub 2 minus x sub 1. And if I want to think about this distance, I'm going to think about that as y sub 2 minus y sub 1. Alright, now what's that going to get me? Well, what I'd like to do is figure out what the distance formula would be. So let's claim this place over here to be the distance between the 2 points. And so since I have a right triangle, I can use the Pythagorean theorem to say, way too small, to say that distance squared will equal x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. A squared plus b squared equals c squared. But I don't want to know what the distance squared is. I want to know what the distance is. So I'm going to take the square root of both sides. So the distance is the square root of the difference in the x's squared plus the difference in the y's squared. That's where our distance formula comes from. Just like our slope formula is, we often say rise over run. Well, our rise is y2 minus y1, and our run is x2 minus x1. Okay. So in today's work, and in fact the next couple of days' work, we'll be using the distance formula, or a rewritten version of it. The other thing I'd like to talk about today, in addition to that distance formula, is the midpoint formula. Now, I know that the midpoint between 5 and 9 is 7. And I know that because 5 plus 9 divided by 2 is 7. If I want to find the point in the middle, I average those 2 points. I add those numbers together and divide by 2. A midpoint is an average of 2 points. So if we go back to our situation where we had x sub 1, y sub 1, and x sub 2, y sub 2, where's the midpoint going to be? Well, I'm going to do the average of these x values, which would be x sub 1 plus y, average of the x value, silly, plus x sub 2, comma, and now the y value is going to be the average of these y values, y sub 1 plus y sub 2. So my midpoint is simply the average of the two endpoints of that segment. The midpoint of a segment is the average of these 2 points, x1 plus x2 over 2, comma, y1 plus y2 over 2. And that's going to be an ordered pair. That's going to be the x-coordinate of the midpoint. That's going to be the y-coordinate of the midpoint. All right. So why don't we see if you're comfortable using it. Here's point A, -7, -4. Point B, 2, 8. And what I'd like to know is, what's the distance between A and B, sometimes written as AB, without a bar on the top. With a bar on the top, remember, is the name of the segment. Without the bar on the top means the length of that segment. But I'd also like to find the midpoint between A and B. Okay, so distance formula. Well, we had this formula, which came from the Pythagorean theorem, x2 minus x1 squared plus y2 minus y1 squared. Well, it doesn't matter if this is x2 or x1. If this is x1, this is x2. If this is x2, this is x1. If this is x1, then this is y1. If this is x1, this is y1. Okay? So our formula then will look like 2 minus a minus 7 squared plus 8 minus a minus 4 squared. And so I get the square root of 9 squared plus 12 squared, which is the square root of 81 plus 144, which is the square root of 225. And the square root of 225, why, that's 15. So I can use my knowledge of the Pythagorean theorem to rewrite it to get the distance formula to find the distance between those 2 points. Okay, so there's number 1, the distance between those 2 points. Well, what about the midpoint? Well, the midpoint is just that averaging the x's, 2 plus -7 divided by 2, and then averaging the y's, 8 plus -4 divided by 2. That's going to be our midpoint when we're done simplifying it. So here, -7 plus 2. Please don't cancel those. Please don't cancel those. Please don't cancel those. Okay, the midpoint between 2 and negative, I'm sorry, the sum of 2 and -7 is -5, and the sum of 8 and -4 is 4. And so I could say -5/2 or -2.5, comma 2 is the midpoint. Well, now I think it's your turn to try. Again, I'm going to want to find the distance and the midpoint in each case. So how about this? A is -2, -1, and B is 1, -3. Please find the distance. Might want to pause the video now, find the distance, come back, and see if your answer is the same as mine. Okay, so we know that D equals square root x sub 2 minus x sub 1 plus y sub 2 minus y sub 1. You know, some people have asked me why it is that I generally start these sorts of problems by writing out the general formula and not just plugging the numbers in. And there's actually a reason for that. And it has to do with wanting to remember this stuff for more than the next half hour. By writing it out every time I do a problem, I'm helping to etch this fact a little deeper into my brain so that when it comes time for a test or a quiz over this stuff, a week or two later, I still have it. Okay, so the distance will be 1 minus a minus 2 squared plus -3 minus a minus 1 squared. Okay, so that's going to be 3 squared plus -2 squared, which is going to be the square root of 9 plus 4, or d equals the square root of 13. I don't need you to decimalize this. If we were doing word problems, I'd probably decimalize it. But otherwise, yeah, that's a fine answer. We've already looked at radicals, and we also know that we can't simplify that, so I'd stop there. Okay, now what about the midpoint formula? Will you please pause the video, find the midpoint formula. Welcome back. So I'm going to average those. X values, and I'm going to average those Y values. And so I end up with -1 over 2, -4 over 2, or -1/2 common -2. Does it make sense in your brain that halfway between -1 and -3 is -2? Does it make sense that halfway between -2 and +1 could be -1/2? I often go through a process like this when I want to confirm that I haven't made an adding mistake. Because we have a lot of work with signed numbers, and signed numbers are consistently the most common mistake, even in pre-cal, I like to check my answer for its reasonableness. Okay, so we said we would be applying these things as well. And so now what I'd like to do is give you 3 points. A is 4, -1, B is 5, 6, and C is 1, 3. And my question for you is, if these are the vertices of a triangle, what kind of triangle do we have? So remember, we can classify triangle by its sides, and we can say scalene, which means no congruent sides. We could say isosceles, at least 2 congruent sides, or the very specific type of isosceles called equilateral, which has 3 congruent sides. And while it's hard for me to classify a triangle by its angles at this point, that'll be next semester we could do that. I can know if a triangle is a right triangle or not. And the way I know that is I plug the side lengths into the Pythagorean theorem. If the side lengths work as a squared plus b squared equals c squared in the Pythagorean theorem, then I can classify that triangle as a right triangle. Most of the ways that we're going to be classifying triangles right now will be based on the sides. And so how can I figure out if 2 sides are congruent or if 3 sides are congruent? Well, I'm going to have to use the distance formula 3 times. Alright, so I'm going to have to find AB, which is 5 minus 4 squared plus 6 minus a minus 1 squared, which is This is going to be 49. This is going to be 1 square root of 50, or 5 root 2. That's AB. We also need to find AC. Okay, 4 minus 1 squared plus negative 1 minus 3 squared. And so I get the square root of 9 plus 16 is square root of 25, or 5. So we know that AC is 5. And then finally, I need to find BC. So Pythagorean theorem again, 5 minus 1 squared plus 6 minus 3 squared. And I end up with 4 squared plus 3 squared. Why? That's the square root of 25. So BC is 5. Okay, so, curiously, I have at least two sides that are congruent, so I know this is isosceles. And do these sides work in the Pythagorean theorem? Well, these are the same. This one is 5 times a number more than 1, so this is a number bigger than 5. So in my Pythagorean theorem, I would put 5 squared plus 5 squared equals 5 root 2 squared. So 25 plus 25 equals 5 squared is 25. Root 2 times root 2 is 2. 50 equals 50. Well, look at that. So we're able then to classify this. Because the sides work in the Pythagorean theorem, we know that this is a right triangle. And because two of the sides are congruent, we can say it's an isosceles right triangle. All right. So, how about you? Classify this triangle? A is located at 7, 3. B is located at 13, 11, and C is located at 5, 22. Okay, let's see about classifying that triangle. So, I guess I'm going to have to find those side lengths, huh? AB is the square root of 13 minus 7 squared plus 11 minus 3 squared. That's going to be 6 squared, or 36. This is going to be 8 squared, or 64. 36 and 64 is 100, and the square root of 100 is 10. Okay, what about A? That was AB. What about AC? So 7 minus 5 squared plus 3 minus 22 squared. Again, AC, 7 minus 5, 3 minus 22. So that's the square root of 2 squared, which is 4, plus negative 19 squared. Is that 381? 19 is 361. Okay, so plus 361. We get square root of 365. 365 is not a perfect root. I see that it is divisible by 5, but it's 5 times 73, and 73 is prime. So that's as far as I'm taking AC. And what about BC? Well, BC's length is going to be 13 minus 5 squared plus 11 minus 22 squared. And so we can say that BC equals the square root of 8 squared is 64. 11 squared is, negative 11 squared is 121. And so that's the square root of 185 for BC. Well, I see that all the side lengths are different, so I know this is a scalene triangle. Now, what about, is it a right triangle or not? How are we able to determine that? That's right, if we plug the sides into the Pythagorean theorem, we should be able to know. Now, this number is almost 400, which is about 20. So we're a little less than 20 here. This is between 10 and 20, but it's much smaller than that one. So I think in the right triangle, this would be my hypotenuse, and these would be the legs. So let's set them up in the Pythagorean theorem. 185 squared plus square root of 100 squared equals square root of 365 squared. So I end up with 185 plus 100 equals 365. 285 does not equal 365, so this is not a right triangle. And you know, were this an honors pre-calc class, we might push the problem further and ask you to determine, is it acute or obtuse then? But no, don't worry about it. I'm just looking for a useful excuse to practice the distance and midpoint formula. And here, here's another one that we should do. Okay. Here's another one that we should think about. We should think about A is negative 3, 2. B is negative 2, 6. C is 2, 7. And D is 1, 3. And you know, I know there's more than three sides here. There's 4 sides, so now we're talking about quadrilateral. Okay, so quadrilateral. So what I want to know is, A, are these the vertices of a parallelogram? And if they are they a type of parallelogram? What types of parallelograms are there, you ask? Sure, there's rhombus. That's a parallelogram with 4 congruent sides. And then we've got rectangle, and that has 4 congruent 90-degree angles. And finally we have square, which is a hybrid of both of those. It's a parallelogram with 4 congruent sides and 4 right angles. Okay, so, and what about parallelogram? Well, in a parallelogram, you know a bunch of things. You know that the opposite sides are congruent, so that these are equal to this, and this is equal to this. You've got a parallelogram. You could also do something with slopes, where you could say that the slopes of opposite sides were the same, because if this slope is the same as this slope, then those sides are parallel. So we could know that this is a parallelogram because two pairs of slopes are equal, or because opposite sides are equal. All right, so let's get to classifying. -3, 2, -2, 6, 2, 7, and 1. So we have something like this, actually. This should be a little further over. That I'm not working on graph paper, but sure, maybe that's a parallelogram. But mostly what I wanted this for was to know which sides I need to find with the distance formula. So, for example, I don't need to find AC, that would be the diagonal. And I don't need to find BD, that would be a diagonal. Though, in a rectangle, diagonals are congruent. So maybe I'll need those distances, but at the beginning, I think I just want to use the distance formula to find these things. So the length of AB is going to be the square root of -3 minus -2 squared plus 2 minus 6 squared. It's -1 squared, which is 1. This is -4 squared, so I get the square root of 17. And then BC is going to be -2 minus 2 squared plus 6 minus 7 squared. It's -4 squared, which is 16, plus -1 squared, which is 1. Ooh, look at that. That's the square root of 17. So this one is root 17, and this one is root 17. Huh. I wonder if all the sides are going to be congruent. Okay, so then let's find CD. That's going to be 2 minus 1 squared plus 7 minus 3 squared. So that's 4 squared for 16 plus 1 is square root of 17. So CD is square root of 17. And then we need AD as well. And so we will do AD is congruent, is -3 minus 1 squared plus 2 minus 3 squared. So that's -4 squared, which is 16. It's -1 squared, which is 1. 16 plus 1. AD equals the square root of 17. All right, well, I know opposite sides are congruent, so yes, this is a parallelogram. But I know also, because all sides are congruent, this is a rhombus. Okay, so what about this one? A equals -2, 2. 1, B equals 1, 4. C equals 2, 8. And D equals -1, 6. Okay, so -2, 2. -1, 6. 1, 4. And 2, 8. So, remember, the first question is this a parallelogram? And then the second question is, if it is a parallelogram, is it a special type of parallelogram, like a rhombus, a rectangle, or a square? So will you please pause the video and do the work necessary to determine whether this is a parallelogram or not. On our quiz for this unit, if you just sort of plot points and say, hey, that's a parallelogram, yeah, I'm not going to give you any credit for it, because I need you to justify mathematically that statement. Okay, so use your distance formula to figure this out. All right, welcome back. So we've got A, oh, B, D is over here, 6 there. Okay, so AB, 1 minus 2 squared plus 4 minus 2 squared. That's going to be 3 squared of 9. That's going to be 2 squared of 4, so I get the square root of 13. And then, what about the side opposite, DC? That's going to be the square root of negative 1 minus 2 squared plus 6 minus 8 squared. So that's going to be negative 3 squared, which is 9. It's going to be negative 2 squared, which is 4. 9 plus 4. Square root of 13. Well, that pair of opposite sides is congruent. But I need 2 pairs of opposite sides to be congruent if this is going to be a parallelogram. So AD, negative 2 minus 1 squared plus 2 minus 6 squared. That's over here. Okay, so that's going to be negative 1 squared, which is 1. This is going to be negative 4 squared, which is 16. 16 and 1 is square root of 17. So this is square root of 17. This is square root of 13, square root of 13. And so I know that this isn't going to be rhombus because the sides aren't all the same. But let's see if it's a parallelogram. BC would be the square root of 2 minus 1 squared plus 8 minus 4 squared. 1 plus 16 is the square root of 17. So this is also root 17. So because the opposite sides are congruent, I know that this is a parallelogram. But is it a rectangle? Well, you know, we could know a rectangle if we had a right angle here. But I couldn't figure out if that was a right angle without finding the diagonals. In fact, I think I want to find the diagonals because better than finding this length and then putting all the lengths in the Pythagorean theorem, I'm just going to take a look at the diagonals. And I want to see if DB equals AC. That'll tell me if I have a rectangle. So let's see now. DB is this one. We're going to have the square root of 1 minus 1 plus 4 minus 6. Okay, that's going to be 2 squared or 4. This is going to be negative 2 squared or 4. 4 plus 4 is 8. So I get the square root of 8 for DB. Now what about AC? Well, AC would be the square root of 2 minus 2 plus 8 minus 2. Well, that's 4 squared. That's 6 squared. 4 squared, 16 plus 6 squared, 36, 40, 52. Square root of 52. Well, square root of 8 is not the square root of 52. So those are two different lengths, and because the diagonals of the rectangle aren't congruent, I know that this can't be a rectangle because these diagonals are not congruent. I do see that opposite sides are congruent, so I know it's a parallelogram. And because these aren't the same, I know it's not a rhombus. And there's no way this could be a square if it wasn't also a rectangle and if it wasn't also a rhombus. So this is only a parallelogram. Okay. Now, next. That's very interesting. note in my notes for this to talk about completing the square. And we will need that in the next video, but I don't think we really need it here. Alright, but we do. I want to go back and review our transformation graphing. It's really important that you don't lose it, and it's been a whole unit since we did it. So, will you please graph this one? Y equals x plus 2 squared plus 1. Okay, start with your reference points and apply the transformations. Come back when you're done, or if you get stuck. So my reference points for y equals x squared are negative 1, 1, 0, 0, and 1, 1. You see this is inside the function, and inside is opposite land, so I need to subtract 1 from all the x's. And this is, subtract 2 from all the x's, thank you. And I need to, because this is outside, add 1 to all the y's. So what are my points going to be that I end up graphing? Negative 3, 2, negative 2, 1, negative 1, 2. So then my graph, it's an upturned parabola. Here's negative 2, 1. Here's negative 3, 2. And here's negative 1, 2. Okay. That was pretty straightforward. Hopefully you retained all that knowledge. Let's go a little further. How about y equals 1 minus absolute x? Why don't you try graphing this and come back when you're done? So a lot of people really struggle with this one. And it's because they forget something that their middle school teacher tried to teach them. The commutative property of addition, that a plus b equals b plus a. Well, if you're not comfortable with this, flip them. Negative absolute x plus 1. Now, it's funny how many students are really comfortable graphing this, but not comfortable graphing this. Okay, use the commutative property of addition. I do see 2 y transformations. Wasn't there something about the order in which we need to carry out 2 y transformations? That's right, we're supposed to follow PEMDAS. So I'm going to multiply all the y's by negative 1. And then I'm going to come back and add 1 to all the y's. So my final points, negative 1, 0, 0, 1, 1, 0. You know this absolute value v is upside down because of that. This is 0, 1, this is 1, 0, and this is negative 1, 0. And of course, you could draw in the axes if you want. Okay, there's the second one. Now, what if we sort of go in a new direction? What happens if I say, hey, how do you graph this one? Or y squared equals x plus 1. These aren't functions. When I see the y squared, I know, like, x equals y squared. If I were to talk about reference graphs, it would look like this. 1, 1, 0, 0, 1, negative 1. Now, this has x-axis symmetry and fails the vertical line test. So this is not a function. And I can only apply my transformations. Those fabulous transformation rules that we know, they only work on functions. This is not a function. So they're not going to quite work that way. But I can certainly give you 2 ways to understand them. And the first is to think about, the first actually, maybe I'll give you 3 ways to think about it. My recommendation is that you find x and y intercepts. Remember, to find an x-intercept, you set y equal to 0 and solve for x. And to find a y-intercept, you set x equal to 0 and solve for y. Okay, so that's the first method. You know when you see a y squared that it's going to be a sideways parabola, and you'll use your x and y intercepts to help you make the graph. So here, if I plug in a 0 for x, meaning I'm finding the y-intercept, I plug in a 0 for x, y squared minus 5. I add 5 to both sides. Now, what am I supposed to remember when I take the square root of both sides of an equation? That's right, there's a plus or minus. So my y-intercept, well, it's actually y-intercepts. I've got 2 of them, don't I? One at positive root 5, one at negative root 5. Okay, what about the x-intercept when I set y equal to 0? Well, if I set y equal to 0, I get x equals negative 5. So let's make a graph of this. So my graph has an x-intercept at negative 5 and has y-intercept at positive root 5 and negative root 5. And there's my sideways parabola. All right, so next method I could use. I could solve the equation for y equals. Yeah, I'm not really keen on this one. So I'm going to add 5 to both sides. And now I'm going to take the square root of both sides. What is it that I'm supposed to remember when I take the square root of both sides? That's right, the plus or minus. But curiously, many students who use this approach forget the plus and minus, and therefore their graph is wrong. And that's why I don't like this approach. So this is actually, I'm graphing 2 things. I'm graphing y equals positive x square root of x plus 5, and I'm graphing negative square root of x plus 5. I'm graphing both of those functions. Well, I see that plus 5, and I know that it moves my square root graph left 5. So instead of this point being at 0, 0, this is at negative 5, 0. And this would be at negative 4, 1. And this would be at negative 3, 2. Is it negative 3? No. Negative 1, 2. I plug a negative 1 in there, and negative 1 plus 5 is 4, square root of 4 is 2. All right, but then I would also repeat that process with this one down here. So I would start with my reference points, and I would subtract 5 from the x's and multiply the y's by negative 1. And so my new points would be negative 5, 0, negative 4, negative 1, and negative 1, negative 2. Negative 4, negative 1, negative 1, negative 2. So that's another way of graphing this. It allows you to use your transformation graphing. And it works. I find it takes a little longer than the other 2 methods. I've shown you one, I still have one more to show you. I think that takes a little longer. And it's the pitfall of the plus and minus that really scares me about that method. So then the last one that I want to look at, the last method for solving this, or for graphing this, x equals y squared plus or minus 5, is to actually look at the graph sideways. So this is x equals y squared. This is x equals negative y squared. So I'm going to look at the graph from over here. When I look at the graph from over here, I see an upturned parabola. When I look at the graph from here, I see a downturned parabola. Negative y squared equals x. So when I think about this, y squared minus 5, I think about, if I'm looking at it from this direction, I'm going to take my y squared and move it down 5. So, lo and behold, I get root 5, get negative root 5, and I get negative 5. That's generally the way I graph, and if I still am not sure about, okay, it's this thing moved that way 5 places, then I use the x and y intercepts to help me graph it. So I've shown you 3 ways. Will you please use one of those ways to graph this? Come back when you're done. Okay, so I like to think that you found the y-intercept by setting 0 for x. So you get y squared equals 1, or y equals plus and minus square root of 1, which is plus and minus 1. So I know we have y-intercepts at 1 and at negative 1. Now, what about an x-intercept? Well, if we set y equal to 0 and solve for x, get x equals negative 1. And there's our sideways parabola. Okie doke. Alright, so how about graphing this one? Y equals to square root x plus 1 minus 3. Will you please graph that one? Okay, so I hope you started with the reference points, because I do like to see some work with these. I see one x transformation, so I subtract 1 from all the x's, but I see 2 y transformations, and we said that we would do PEMDAS when we have 2 y transformations. So I have to multiply all the y's by 2, and so I'm going to have negative 1, 0, 0, 2, 3, 4. But I still have to come back and subtract 3 from all the y values. And so the points that I'm going to graph and the points that I'm going to label my graph with: negative 1, negative 3, 0, negative 1, and 3, 1. Okay. Negative 1, negative 3, 0, negative 1, that's the y-axis, and 3, 1. And I know that halfway in between those will be the x-axis if you really want to graph it. Can we find what the x-axis is? Well, to find the, x-intercept, I set y equal to 0. Add 3 to both sides, divide by 2, and then I have to square both sides. So that's going to give me 9/4 equals x plus 1, and when I subtract 1 from both sides, I get 9/4 minus 4/4 or 5/4. So if you wanted, you could certainly label the x-intercept here as well. All right. That was good. And one last graphing problem, and then we'll call it a day. Oh, no, wait. We have to play What's My Quadrant. All right. So, this is the last one. y equals negative 2x plus 5 cubed plus 4. Please graph that one. Okay, welcome back. I hope you started with proper reference points. -1, -1, 0, 0, 1, 1. If you didn't, you might want to pause the video again and try graphing again now that you see the correct points. I see two y transformations. I need to do PEMDAS, so I multiply the y's by -1, then add 4. What about two x transformations? Do I also follow PEMDAS? No, I follow SADMAP. SADMAP says I need to subtract 5 from all the x's and then divide the x's by 2. So I'm going to multiply the y's by -1, and then I'm going to subtract 5 from all the x's. So my transition points would be -6, 1, -5, 0, -4, -1. And then I'm going to come back for another round of transformations. I'm going to add 4 to all the y's. And I'm going to divide all the x's by 2. So we end up with -3, 5, -5 halves, 4, -2, 3. And my graph, because of this negative, has been reflected. So my graph looks like this now. Here's -5 halves, 4. Here's -2, 3. And this point over here, -3, 5. All right. Well, hopefully you're still comfortable with your graphing, because it's coming around again soon. And the last thing I want to do with you is play a couple of rounds of what quadrant do I live in? Not life, but live in. So remember, in first quadrant, ordered pairs are positive x's and positive y's. And in second quadrant, we have negative x's but positive y's. In third quadrant, we have both negative x's and negative y's. And in fourth quadrant, we have positive x's again, but still have negative y's. So, hi, I'm point A. And point A has x is less than 0 and y is greater than 0. In what quadrant must point A live in? X's are less than 0, y's are greater than 0. 5, 4, 3, 2, 1. Yes, A is in quadrant 2, where the x's are negative and the y's are positive. What happens if I switch that, where the y's are less than 0, but the x's are greater than 0? In what quadrant would we be in then? 5, 4, 3, 2, 1. Well, that would be here in fourth quadrant with negative y values, but positive x's. All right. So how about this one? X, y is less than 0. What quadrant or quadrants would I have to live in? What quadrant or quadrants would I have to live in if x times y was less than 0? Well, in order for this number to be less than 0, one of these has to be negative. So I'm not going to be in this quadrant where both of them are positive. I'm not going to be in this quadrant because both of them are negative. A negative times a negative is a positive, not less than 0. But what about these quadrants? A negative times a positive is negative. Positive times a negative is negative. Oh, so I'd be in quadrant 2 or 4. Okay, we will be playing What's My Quadrant throughout the year with different contestants. And that's our first round. All right, I hope this was helpful, and I hope you're ready to start our next unit, which has a little bit before we get to functions. But most of this next assignment calendar is functions, except not at the beginning. So that's why there's a little line there that says, no, functions doesn't really start until after this stuff. But we will, in the next few videos, get over to functions. Right now, we're just going back and reviewing some basics before we head into the next assignment, circles, with completing the square. Now, I do want to say that tonight's assignment is assignment 28. I've scanned the pages from the textbook for that assignment and loaded them onto Office 365, so they're there waiting for you. All right, have a great day, everyone. I hope this was helpful.